Dead Sea Scrolls, we'll, in this presentation, we'll look at how we date the Dead Sea Scrolls and determine, what time period that the Dead Sea Scrolls can be found. And Wei did mention in her presentation that the scrolls are dated between the 3rd century BC and the 1st century AD. And so we'll look at how those dates came about. And can everyone hear me okay?
Yeah,
Yeah.
yes, we can.
Okay, great. All right, so we'll look at 2 methods of dating the scrolls. One of them uses paleographic dating, and the other method is radiocarbon dating. And these are really the 2 primary methods that are used for dating the scrolls. And so first we'll take a look at paleographic dating. The picture here that I'm showing you is a picture of the Nash Papyrus. It's currently located at the Cambridge University. It is not one of the Dead Sea Scrolls, but it was dated with paleographic methods. It was found prior to the Dead Sea Scrolls, and the dating of the Nash Papyrus actually kind of became foundational for dating all of the remaining, or all of the Dead Sea Scrolls. So when it comes to paleographic dating, there's really 2 primary components that are involved. The first is to establish a record of a handwritten script's progression through history using firmly datable evidence. And so this usually comes in the form of other manuscripts and inscriptions that reference some specific historical events or markers or rulers, etc., that gives us, some kind of anchor point in which to date that particular document or inscription. And then we take a series of those and then try to extrapolate somewhat of a linear fashion. How did that particular script progress between the periods that we can firmly date? And then the second part, once we have this index of progression of the script, is to take the handwriting found in a manuscript that we want to date and then compare it with that index that we've established. Now, when it comes to paleographic dating of the Dead Sea Scrolls, there are really 2 primary scholars that we'll talk about today. And Wei mentioned or quoted something from Cross in her presentation. So we'll look a little bit more about Cross. But first, we want to talk about Albright. And both of these men have since passed, but you can see the different time periods that they worked. Now, Albright, you may be familiar with him, and we'll talk about him in here more. He was the W.W. Spence Professor of Semitic Languages at Johns Hopkins University. And he was also the director of the American School of Oriental Research in Jerusalem from 1922 to 1929. He's probably most known for this next part, which is he was the leader, really he's a leader in the field of biblical archaeology. He established essentially the standard index of pottery chronology, Near Eastern pottery chronology. If you're familiar with some of the biblical archaeological aspects, or if you've taken anything from Joel Kramer, or you're familiar with the archaeology around Jericho, you know that the pottery chronology is a very important part of determining the dates of things like Jericho. And Albright is the one who basically world expert and established the chronology of pottery chronology. So that's what he's most known for. But in terms of the Dead Sea Scrolls, he also had a major role in determining that the Dead Sea Scrolls were authentic. So right away when they were found, they brought him in, and he said, yeah, these are legit. But his contribution primarily to dating the Dead Sea Scrolls really happens a decade before they were actually discovered. And that's because he applied his paleographic approaches to the Nash papyrus that I had just shown you on the previous slide. His work on the Nash papyrus, again, became foundational for the paleographic dating of the Dead Sea Scrolls. Now, Albright used an extensive set of primary evidence to establish the evolution of Northwest Semitic scripts from the Aramaic cursive of the 5th century BC to the Dura Europus papyrus that dates to just before 256 AD. And one thing I will say here is there was some work that was done on the Nash papyrus before Albright. And as was the case, and we'll see also when we get into Cross, each of these scholars were in a very, which had to have been a very exciting time at the end of the 19th, in the early, first half of the 20th century, because every time you read about the work of these scholars, it's like they had more evidence. There was more discoveries. They had more manuscripts, more inscriptions, which allowed them to draw more complete or more specific, precise conclusions. And so that was the case here as well. He had additional evidence that wasn't available before that he applied to developing this progression of the Aramaic cursive to the Dura Europus papyrus. And he used that to establish that the Nash papyrus dated from 165 to 37 BC. Basically, during the Hasmonean period, he called it the Maccabean period. He was the first to actually use that term in the scholarly writing in reference to the time period for dating purposes. He also established the earliest possible date for the manuscripts to be around 250 BC. Now, notably, and I believe correctly, Albright was comfortable with a broad date range, and he was not emphatic about establishing a very specific or narrow range of dates. We'll see that that mindset changes when we get to Cross, by the time we get to Cross. And we'll talk about that in a moment. Now, Albright used Aramaic papyri and ostraca from Egypt to determine the earliest possible date for the Nash papyrus. And you can kind of see here in these first two columns, these are some of the pieces of data that he had. And this comes from one of his writings from 1937. He also compared it with contemporary Nabatean and Palmyrene inscriptions. So we all know about Palmyra, and there's inscriptions there, and those inscriptions were used to help date the Nash papyrus and ultimately the Dead Sea Scrolls. He also established the latest possible date by comparison with Herodian era documents and inscriptions. And so again, that forms the next two columns of his table here. And you can see that the Nash papyrus falls right in the middle. Now, before we go to Cross, there is one person I want to talk about briefly, and that is Solomon Birnbaum. He lived from 1891 to 1989. That was a great year in 1989, other than he passed away, because that's the year I graduated from high school many years ago. So what's interesting about Birnbaum, though, is that he established that the Nash papyrus preceded the Isaiah scroll, the Great Isaiah scroll, and he did that based on paleographic evolution. But he also asserted that even though the Nash papyrus preceded the Isaiah scroll, that they were very close together chronologically. Thus, he established the relative terminus post quem for the Isaiah scroll, the earliest point that it could be. And his conclusion was, our investigation has shown that Aleph, Daleth, He, Vav, Teth, Yod, Mem, final Mem, He, Kof, Kaf, and Ta, i.e. nearly half the letters of Isaiah are of a somewhat later date than those of the Nash papyrus. He goes on to say that Isaiah is most likely 25 to 50 years later, which again, to me is somewhat interesting because initially I'm thinking about this type of dating and I'm thinking of centuries. You know, they find it within 100 years or maybe 50 years, but generally 100, 200 years, broad ranges. And he's able to get it down to it's probably 25 or 50 years. And here's some of the work that he published when he did this analysis. And we can actually kind of see a lot of similarities and some differences. The first 4 rows are from the Nash Papyrus. And the bottom 2 are from the great, a facsimile of the great Isaiah scroll. So again, when you look at these characters going down the rows, you can see that, in many cases, the Nash Papyrus and the Isaiah scroll, the characters look very similar. But there are in some instances where the letters start to change a bit more, have a little bit more development. And so that's what he was pointing out. And that's how he established that they are close together, but Nash came a little bit earlier. So quick recap. Albright says the Nash Papyrus is written sometime between 165 and 37 BC. Birnbaum says, whatever the Nash date is, the Isaiah scroll comes later than it, but not by very much. And so that's where we end with those 2 scholars. And notably today, the Nash Papyrus is dated between 150 and 100 BC, and the Great Isaiah Scroll is dated to around 125. So the work of these early scholars that looked at this has remained fairly close with only minor tweaks and adjustments to our modern time by subsequent scholarship. Now we come to Cross. Cross was the Hancock Professor of Hebrew and other Oriental languages emeritus at Harvard. And he studied under William Albright that we just looked at. And interestingly, the PhD students that Cross mentored included Emmanuel Tobe, John J. Collins, Bruce Walke, Joanne Hackett, and many other notables. People that we're studying and their works. Cross was their mentor. And he started working on Cave 4 discoveries in 1953. And he did assert that dating based on Jewish paleography had become more of an established science at this point, and that because of that, we could date manuscripts and inscriptions within fairly narrow date ranges. And he defined these date ranges kind of summary fashion. I would define them as within a generation. That's kind of the terms that he used. And more specifically, within 25-year intervals. And Cross then applied these narrow date ranges to the scrolls from Cave 4. And again, we have to remember that also with Cave 4 came many more discoveries and manuscripts. But also by that time, there were other data, inscriptions, evidence that had been found. So he had more material to work from to establish his chronologies than Albright had before him. Now here's a table of his work. His original work was in 1961. There was a revision to it in 1998. And you can see going down the list of documents, again, they're predominantly all Q4 from K4. And he'll say, okay, this one is in the mid 3rd century, so that's about 250 BC. And then we get to 225 BC. We come down to this one, we see that it was 200 to 175. Then we changed it to 200 a little more specifically. We have 175 to 125, and then we have 175 to 150. And as we go through this, 175, 150, 175, 150, 125, 100, 50 to 25, we can see that Cross is somewhat pigeonholing pigeonholing each of these manuscripts into a, kind of a 25-year time period. Sometimes it's a little more, sometimes it can be a little bit more precise for a variety of reasons, as in the last one, which was internally dated and had a reference point. So again, he's breaking it down. Now, Cross's index for the evolution of Jewish paleography during the time period that he worked on has been very helpful. And basically, it became the standard, much like Albright's pottery chronology. Cross's index of Jewish script was, again, the standard for a long time. But the level of his discrete breakdown into 25-year intervals has been rightfully criticized. And I will demonstrate this with a modern example. So we'll look at the evolution of the English text during the lifetime of Dr. Bookman thus far. And so here are 3 samples of English text in and around my home. And a couple of these came from a recipe box, and one of them came from an unknown electronic device, presumably unknown. Now, looking at these 3, this is the interactive part of the presentation. Looking at these 3 examples of English text, which one do you think came first?
C.
C, exactly. Which one do you think came last?
B.
B, exactly. Now, this shows a couple of things. One, we have a change in how we include emojis and everything else. I meant to include like a 3-letter acronym like LOL and a few others, and show how our English language now with texting is continuing to devolve into 3-letter acronyms and beginning to look much more like Hebrew. But if I went to show you the next slide, and I put these in order, and I put dates with them, and I were to show you that this recipe really comes from about 1950 to 1975. This other one comes from 1975 to 2000, and this one comes from 2000 to 225, then you probably would not dispute these dates too much. We could all be confident on this one. We know many of us in our lifetimes have seen the transition from cursive writing to predominantly print and now predominantly typing. And I mean, that's happened in my lifetime. And so that is, within reason. But also it highlights that, we may just, have some academic, some scholarly debate about, well, did cursive really stop, kind of 1975 or did it go on a little bit into the 80s? Okay, well, maybe it went on a little bit into the 80s before everything went to print. And again, that's a legitimate conversation. And those are the kinds of things that happen at the academic scholarly level as more evidence becomes available and they refine it, which is why today we look at the dates of the Isaiah scroll. They're a little different than Albright and Cross, or Solomon, but not by much, or Birnbaum. So now, what can we conclude from this? We can see that writing does evolve and change over time. The rate of change from generation to generation is not something that can be set in stone, but it makes sense as a general rule of thumb. Sometimes it'll be faster, sometimes it'll be slower. But again, it's a reasonable starting point. But there's one big problem with Cross's approach. And that is, my mom and my grandma did not stop writing in cursive when all the youngsters switched over to just using print. My mom still writes in cursive in 2022. And my grandma did up until she passed away a few years ago. So there can be considerable overlap during the points of transition. These transition points are not hard switchovers. A new pattern steadily becomes predominant as the older one gradually fades out of use. So, summary of paleographic dating. There are 900 Dead Sea Scrolls, and they have all primarily been dated using paleographic methods from 225 BC to 50 AD. Paleography is an established method with a fairly well-established timeline for the progression of relevant scripts. And we have a reasonable quantity of manuscripts and inscriptions to compare with. It's not destructive. It dates the actual text and not the material it's written on. And it's generally accurate to plus or minus 50 years or so, sometimes a little better, sometimes a little worse, depending on the time period and the amount of evidence and other things to compare with that's available. So now let's switch to the second method of dating the Dead Sea Scrolls. And that is radiocarbon dating. And by the end of this presentation, you're going to understand what this funny chart here means. Now, there are 7 key principles that I want to highlight here. And the first is that there are 3 naturally occurring isotopes of carbon: carbon-12, carbon-13, and carbon-14. Both carbon-12 and carbon-13 are stable, and while carbon-14 is radioactive and decays. Because carbon-12 and 13 are stable elements, they exist in fixed quantities. We have a certain amount of them, and they don't change. They're not created, they're not destroyed, where carbon-14 is made as a result of radioactive processes and decays in the same fashion. The half-life of carbon-14 is 5,730 years, plus or minus 40. Carbon-14 is constantly produced in the upper atmosphere as a result of nitrogen atoms interacting with cosmic rays. And because it's up in the upper atmosphere where these mechanisms initiate and begin, and the whole planet is covered with an atmosphere, the amount of carbon-14 in the environment is highly uniform. All living organisms, including you and I, have a carbon-14 level that is in equilibrium with their environment and our environment. So whatever the atmospheric level of carbon-14 is, it's in us as well in the same proportions. When an organism dies, however, it stops interacting in bioprocesses in terms of interacting directly with the atmosphere in us. And so its carbon-14 levels immediately begin to decrease. Now let's talk a little bit about the creation. Cosmic rays collide with atoms in the upper atmosphere, as I mentioned, and this causes free neutrons to be produced from the nuclei. These free neutrons are then captured by nitrogen atoms, just 7 protons and 7 neutrons, in a process that also liberates a proton. The end result is carbon-14 with 6 protons and 8 neutrons. So take nitrogen, you kick out a proton, you get 6, you add a neutron, you get 8, and that's where carbon-14 comes from. Now, this carbon-14 oxidizes into carbon monoxide and then further into carbon dioxide. At that point, it enters into the ecosystem and biosphere, initially primarily through plants and photosynthesis. And the plants get eaten by animals, the animals get eaten by other animals and people, and some people even eat plants, and then that's how we get carbon-14. Now, the amount of carbon-14 existent on the Earth is very, very small. It's actually about 1 part per trillion carbon atoms. But because carbon-12 and 13 are stable, they also exist in very stable proportions. For carbon-12, it's 98.9%. Carbon-13, it's 1.1%. And again, there's a very, very small fraction that is carbon-14. Now, theoretically, Due to the constant rate of radioactive decay, we can determine how long ago something died by the amount of carbon-14 that remains. If we know how much carbon-14 was in something when it died, and we measure how much carbon-14 is left, then we can do some fairly simple math to determine the number of years that have transpired. Procedurally, though, this is important, radiocarbon dating is based on a simplistic model, and then that model is modified to align with reality. So it's kind of a two-step process. So let's start by talking about the simplistic model. Well, first off, interestingly, the baseline year used in radiocarbon dating is 1950. So all radiocarbon dates are given using a BP notation, which is a reference that means before present. But the before present date isn't 2022, it's 1950. It's always 1950. Thus, a date of 500 BP would equal 1450 AD. Be 1950, I should say AD here. 1450 minus 500 takes us back to 1450 AD. The model also assumes that the level of atmospheric carbon-14 has remained constant throughout all time. Now, interestingly as well, the model uses a half-life for carbon-14. That's incorrect. Instead of 5730, it uses 5568. And that's again for historical purposes, because when the process was first created and in its early stages, we did not know the half-life of carbon-14 as precisely as we do now. And things were measured and estimated and dated using that date. And so to basically maintain compatibility with those previous test results and so forth, they decided to use 5568 as the year they used to calculate, or the half-life they used to calculate these before present dates. And this date is known as the Libby half-life, after Willard F. Libby, the inventor of radiocarbon dating effectively, and also he won the Nobel Prize in Chemistry for it. Now, the Isaiah scroll has been dated with this method 3 times. Once at the lab of Tucson, and it came up with a before present date of 2142, plus or minus 32. In Zurich, and they came up with a before present date of 2128, plus or minus 38 years. And then also Libby did an early test at the University of Chicago. Their laboratory was renamed after Libby because of his historical significance. But again, it's primarily only of historical interest. The first two, however, the first 2 labs are important, but we need to remember that these radiocarbon years are not calendar years or dates. So you can't just take 1950 and subtract 2142 and say, oh, that's the date on the calendar. That's how far it goes. So we have to align that date with reality. And we do that through calibration curves. Calibration curves are created to calibrate the raw result provided by the simplistic model and effectively convert it to a calendar date range. These curves account for the incorrect half-life of carbon-14. Actually, the adjustment of the ratios happens on the first phase, so I'm not going to worry about that one. Most importantly, the curves correct the errors from assuming a constant level of carbon-14 in the environment. Everyone recognizes that that assumption isn't true, so we have to correct for it. And how do we do that? Well, calibration curves are created primarily based on dendrology, the study of tree rings. So we start with trees with a known time of death. We count their rings, we measure their carbon-14 levels, and we can kind of see, what the level of carbon-14 was at the time that they died, working backwards. And because we can look at tree rings in one tree and the tree rings of another tree that had died earlier, but the tree rings overlap, we can kind of produce a record that goes back by these overlaps of tree rings to 5,000 or 6,000 years. Some will claim 15,000 years, but all stick to a younger Earth. Now, this record is then used, that is created from these tree rings, to account for the actual carbon-14 levels throughout history. Now, these curves are updated every few years, and the use of different curves from different years may produce different results. But these different results generally are not overly material. But an interesting and important note, and I didn't realize this until doing this study, is that the level that we have of carbon-14, and we go from that raw date, because those levels have gone up and down over time in the environment, it's possible for two different calendar date ranges to produce the same raw carbon-14 date. So you can't just say, oh, this goes back 2,142 years. That corresponds to X date. There could actually be two ranges on the calendar that could give us the same result. The calculations to convert between raw and calendar dates are very complex and requires computers. And online access to some of these is available. And so I went to one at Oxford University, and I put in the dates for the Isaiah scroll. And this is for the ones from the Zurich lab in 2128, plus or minus 38 years. And notice I'm using the calibration curve from 2020. And when we do this and we calibrate, we get a curve that looks like this, which we looked at the beginning of the section. Now, when you look at this bell curve here on the side, this corresponds to the raw carbon date that was given of like 2138 plus or minus 32 years. And so now we get this bell curve because that plus or minus is our standard deviation. This blue line represents the calibration curve and how the levels of carbon-14 in the environment have changed over time. And this is effectively the correction factor. And then these it ranges on the x-axis, along the x-axis, correspond to calendar dates that could produce the amount of carbon-14 that remains in the sample. And you'll notice here that there's actually 3 date ranges that are given. And those 3 date ranges are explained up here above. The first one is from 350 to 390. There's a 14.5% chance that that's the date range that corresponds to the Isaiah scroll. Similarly, there's 226 to 223, a scroll in that time period. That's less than half of 1%, but it was enough to report. And then there's an over 80% chance that the Isaiah scroll happened in this time period. And it just so happens that right smack in the middle of this, the year is 127, which is very close to where we date the scroll today. Now notice that all of these dates are given here now with cal. That tells us that these date ranges have been corrected and calibrated using curves. This isn't the raw data. And also note that at times, it's possible that there's actually 0 chance that something between these date ranges could work. So right here, we have a little residual gray, but there are examples, and I saw some of them, where it could be one date range, and you can have another date range. And those date ranges may be 50 or 80 years apart, but there is absolutely 0 probability that the scroll or the sample that you're testing died in the time in between those ranges, which was an interesting thing to learn as well. Now, I mentioned there's multiple curves. I'll just real quickly go through the curve with 1998. And when you look at the 1998, again, using the same Zurich data, you'll see that the kind of the endpoints of the ranges shifted very little. The percentages changed just, a couple of percentages. And that's generally the case. It's not always true, depending on the date period and so forth, but in general, that is the case. Same thing if we use the curves from 2004. Again, some adjustment on endpoints, some adjustment in the percentages overall for these various segments, but the overall significance is minor. So, overall summary of dating the Dead Sea Scrolls with radiocarbon dating. In 1991, the lab in Zurich tested samples from 14 scrolls. In 1994 to 1995, the lab in Tucson tested samples from 22 scrolls. And often the results are requested from more than one lab. And this is again for being just scientifically rigorous and have some confirmation from results. And these results, the raw data and also calculated data or calibrated data, are available online on Wikipedia. But they're also available from original published lab reports. And again, as I mentioned earlier, the testing of the Isaiah scroll by the Liddy lab is primarily only of historical interest. All of the radiocarbon dating performed on the Dead Sea Scrolls has generally been consistent with the dating determined by paleographic methods, which we would assume if we're using two scientifically valid techniques, we would expect them to have similar results. And overall, the radiocarbon dating has given us, a wider range, but from 385 BC to 82 AD. It's important to note, though, radiocarbon dating is destructive. It requires a physical sample of, the size required now is not as much as it was in the 60s, let's say, but it does require a sample to be taken from the document, from the material, and then that it is subsequently destroyed in the process of taking the measurement. So you can see why we don't radiocarbon date all the fragments and manuscripts that we have, because if we did, we would be destroying the little evidence that we have sometimes. And radiocarbon dating doesn't actually date the text. It only dates the material it's written on, which must be organic. It has to have been alive and died in order for it to be datable. So conclusions overall. Both paleographic and radiocarbon methods have their place. They represent two scientifically based tools to date ancient manuscripts, which together can be used to provide confirmation across techniques. Overall, paleographic methods have more utility since they can provide narrower date ranges, they're non-destructive, and they can be used for writings and inscriptions on non-organic material. However, radiocarbon methods can be used in instances where the text of a manuscript is largely illegible or it's insufficient for paleographic use. So with that, I will open it up to questions.